Given the integral of 1 over the square root of x squared plus 6x plus 13 dx, we would like to use trigonometric substitution. The first step in using trigonometric substitution is to complete the square of the square root of x squared plus 6x plus 13, which is equal to the square root of x squared, or x plus 3 squared plus 2 squared. Do you notice anything familiar about this? Well, it's the hypotenuse of a right triangle. If we write this in terms of a triangle, we can say that one side is x plus 3, and the other side is 2. Therefore, we know the hypotenuse is the square root of x plus 3 squared plus 2 squared. Given this triangle and this information, we can rewrite our original integral as the following. Because we've completed the square and we found out that this root is equal to this, we've rewritten our original integral as the integral of 1 over x plus the square root of x plus 3 squared plus 2 squared dx. Therefore, we know that dx is equal to 2 secant squared d theta, or 2 secant squared theta d theta dx. So 2 secant squared theta d theta. And we know that x plus 3, x. Now that we substituted dx over here, we need to finish substitution on the bottom to write our integral in terms of theta. We know that x plus 3 is equal to 2 tan theta, so x plus 3 squared is equal to 2 tan theta squared. Over here, it's 4 tan theta squared plus 4. 2 squared is equal to 4. We can keep simplifying this and pull out the 2 from 4 tan theta squared plus 4, because you factor the 4 out and take the square root of that. We know the basic trigonometric identity that tan squared theta plus 1 is equal to secant squared of theta. Therefore, if we take the square root of secant squared theta, we get this. 2, bring your 2 down, and secant squared. Now simplifying this, cross out one of your secants, you get secant of theta, d theta, 2's also cancel. Square root of secant theta, d theta, as we've done before, is equal to ln of the absolute value of secant theta plus tangent theta. Knowing this, we can find our final answer. Secant theta, as you can see from our triangle, is equal to square root of x plus 3 squared plus 4 over 2. You can observe from the triangle. And tangent theta is equal to x plus 3 over 2. Therefore, our final answer is
so another essential part of the trigonometric substitution is regarding sine of x's and cosine of x's. So a classic example of this type of question would be the integral of sine squared of x times cosine third of x dx. So what do you do when you go about solving one of these questions? Well, the first step is to look at the powers of the sine of x and cosine of x. If the power of the sine of x is even, then you use u as your then you use u substitution and set u as sine of x. If your cosine, the power of cosine is even, then you set u as your cosine of x, and dx then becomes negative sine of x. Well, in our case, we have the power of sine of x as even, so essentially we're saying that u would equal sine of x, and du would then become cosine of x. However, we come across a problem. We have cosine to the third of x. We only want a cosine of x. We don't want any more than a cosine of x, because then our u substitution wouldn't work out well. So what do you do when you face this challenge? Well, since you have the identity sine of x, sine squared of x plus cosine squared of x equals 1, you can essentially say that if you take this and make it into a cosine squared of x times cosine of x, because this is equal to cosine to the third of x, then a cosine squared of x would equal 1 minus sine squared of x. So, doing that substitution, you would get the integral of sine squared of x times, since cosine squared of x is equal to 1 minus sine squared of x, you can rewrite it as 1 minus sine squared of x times cosine of x, because you have an extra cosine of x times dx. This is what you end up with. Okay? So, getting to this step, you can then go about your actual u substitution. Since du equals cosine of x dx, this becomes du. Okay? And u is sine of x. So, rewriting this integral with the u substitution in, you would get u squared times 1 minus u squared du. Okay? So, knowing that, then you can distribute this out to equal the integral of u squared minus u to the fourth du. Then, since this is merely a an integral regarding powers, it's very easy to integrate. So, doing the integral of this, you will get u to the third over 3 minus u to the fifth over 5 plus c. Now, you're almost done with this question, but there's one last step. You have to substitute sine of x back into u to complete this integral. So doing that, u to the third minus over 3 minus u to the fifth over 5 plus c would give you sine cubed of x over 3 minus sine to the fifth of x over 5 plus c. And that is your final answer for the integral of sine squared of x cosine third of x dx.
So, we just saw sine x and cosine x in their versions of the trigonometric substitution. However, secant x and tangent x aren't exactly the same, because when you take the derivative of either one of these, or rather for secant x, it becomes two functions, secant x and tangent x. And when you take the derivative of tangent x, it becomes a function squared. So with this problem here, secant to the fourth x times tangent third x dx is the integral we're trying to find. And a common property of trigonometric functions is 1 plus tangent squared x is equal to secant squared x. And these squared properties are key in finding trigonometric substitution integrals. And what we're going to do is we're going to use u substitution combined with this property to find the integral of this function. And we're going to set u as secant x. So therefore du dx is going to be secant x tangent x. So when we rewrite this problem, what we have secant to the third x times secant x times tangent x times this property here, where we rewrite 1 plus tangent squared x equals secant squared x as tangent squared x is equal to secant squared x minus 1 dx. Or rather, du over secant x tangent x. So we've introduced this du, which means we now have to substitute for sine x. And here the secants cancel out, and so does this one tangent power. So when we go to rewrite this, we have integral of u to the third times u to the second minus 1 du. And this is just clearly a power function, so this becomes integral of u to the fifth minus u to the third du. And the antiderivative of this is u to the sixth over 6 minus u to the fourth over 4 plus c. And this is substitution, so we need to unsubstitute. Therefore, this becomes secant to the sixth over 6 plus secant to the fourth over 4 plus c. And this is your answer to this.